Imagine a ray of sunshine illuminating a dusty attic. Notice how objects, even slightly separated, cast soft shadows, adding depth and realism to the scene. This interplay of light and shadow, often overlooked, is crucial for creating convincing 3D graphics. In the realm of 3D modeling and rendering, we replicate this phenomenon using powerful techniques: ambient occlusion and lighting maps. These techniques, though seemingly complex, are essential tools for breathing life into our digital creations. This essay delves into the fascinating world of ambient occlusion and lighting maps, unveiling their mysteries and empowering you to wield their power in your own 3D projects. Whether you're a budding artist or a seasoned professional, understanding these concepts will undoubtedly elevate your work, adding a touch of realism and artistry. Ambient occlusion, or AO as it is commonly known, is a shading technique that simulates the subtle darkening that occurs in crevices and contact points where ambient light is partially or completely blocked. Think of it as a virtual layer of dust that accumulates in the nooks and crannies of your 3D models. This dust creates subtle shadows, enhancing the perception of depth and realism. In essence, AO analyzes the geometry of your scene and calculates how much ambient light can reach each point on the surface of your models. Areas that are more occluded or blocked from receiving light appear darker, while areas that are more exposed appear brighter. Just as there are various ways to paint light and shadow, there are different methods for calculating and applying AO. Each technique has its strengths and weaknesses, offering a trade-off between accuracy, speed, and computational cost. Let's explore some of the most common types of AO. Screen Space Ambient Occlusion, or SSAO, is a popular technique that analyzes the depth buffer of the rendered image to approximate ambient occlusion in real time. SSAO is relatively fast and efficient, making it suitable for interactive applications like video games. Ground truth. Ambient occlusion, or GTAO, as its name suggests, calculates AO based on the actual geometry of the scene, resulting in highly accurate results. However, GTAO is computationally expensive and is typically used for offline rendering, such as in films and high-quality animations. Ray-traced ambient occlusion utilizes ray tracing, a rendering method that simulates the path of light rays to calculate AO with exceptional precision. Ray-traced AO produces the most realistic results, but is also the most computationally demanding. Section 4. The art of lighting maps, illuminating virtual worlds. Lighting maps are a powerful tool in the 3D artist's arsenal, allowing us to pre-compute and store lighting information for our scenes. Imagine baking a cake. You mix the ingredients, bake them in the oven, and the result is a delicious treat that's ready to enjoy. Similarly, lighting maps bake lighting information onto textures, saving valuable processing power during rendering. Instead of calculating lighting in real time, which can be computationally intensive, lighting maps provide pre-calculated lighting data that can be quickly and efficiently applied to our models. This not only improves performance, but also grants us greater control over the final look of our scenes. Section 5. Exploring different lighting maps, a map for every need. Just as a cartographer uses different maps for different purposes, 3D artists employ various types of lighting maps, each optimized for specific lighting scenarios and effects. Let's navigate through some of the most common lighting maps, light maps. These maps store direct, indirect, and ambient lighting information, capturing the way light interacts with the surfaces of our models. Light maps are particularly useful for static scenes, such as architectural visualizations, where lighting doesn't change significantly. Radiosity maps. This type of lighting map focuses on capturing indirect illumination, the soft, bounced light that fills our environments. Radiosity maps are known for creating a sense of warmth and realism, especially in interior spaces. Spherical harmonics, SH, maps. These maps use a mathematical representation of light to store and reconstruct lighting information. SH maps are computationally efficient and are often used for dynamic lighting scenarios, such as in video games.